Let's look at linear equations in two variables. So here I've given you an equation, y equals x plus 7. And I want to see if negative 1, 6 is a solution to this equation. So a solution to the equation means that if we look at the line x plus 7, y equals x plus 7, then we will have infinitely many solutions to this equation. And we're looking to see if negative 1, 6 is just one of them. So when we look at this, we'll put negative 1 where we see the x and 6 where we see the y. So we have 6 equals negative 1 plus 7. Well, 6 equals negative 1 plus 7 is 6. So that means it would be a solution. Let's look at another. If we have 2x plus 3y equals 6, and let's see if the point 1, 1 is a solution. So that means we put a 1 where we see the x, plus 3, 1 where we see the y, and we want to see if that equals 6. 2 times 1 is 2, 3 times 1 is 3. Does 5 equal 6? Nope. So that means that 1, 1 is not a solution. That means if we were to draw our line representing this equation, the point 1, 1 would not fall on that line. So if we look at our graphing axes, we have a couple of pieces to consider. Over here, we have our horizontal x-axis. We have our vertical y-axis. We have our origin, which is right here where the x and y-axis come together at the point 0, 0. And then all along the graph, we have all of our ordered pairs that represent all of these other points. If we wanted to draw a graph, there are many ways that we can go about this. One option is to make a table. So if I give you the equation y equals x plus 7, and we wanted to draw a table, what we would do is consider the x values and the y values. So let's say that we picked a couple x values. It's always nice to use 4 or 5 points so that if you have one that doesn't line up, you can see that. So how about we use negative 1, 0, 1, and 2. We can throw a negative 2 on there as well. There we go. Now we have 5 nice values. So to find y, we substitute our x in for right here. So that's going to look like negative 1 plus 7. Well, negative 1 plus 7, that gives us 6. If we substitute 0 right here, that's going to look like 0 plus 7. 0 plus 7 is 7. If we substitute 1 in right here, that's going to look like 1 plus 7. 1 plus 7 is 8. If we substitute 2, that's going to look like 2 plus 7. 2 plus 7 is 9. If we substitute negative 2, that's going to look like negative 2 plus 7, which is 5. So let's draw our graph. Each of these represents an ordered pair. Our first ordered pair is negative 1, 6. So that means we go negative 1 on the x-axis because x is correlating to negative 1. That's here. And we go up to 6. So let's see, 1, 2, 3, 4, 5, 6. Negative 1, 6 looks like it would be right there. Next we have 0, 7. So that's right here. We have 1 and 8. 2 on the x, 9 on the y. Negative 2 on the x, 5 on the y. We can connect our dots. And now we have graphed our equation. Let's try again. We have x plus 2y equals negative 5. Let's make our x and our y. So let's use, how about negative 1, 0, 1, 2, and 3. So this means we put negative 1 where we see our x. Well, if we do that, we are substituting in negative 1 right here. So negative 1 plus 2y equals negative 5. Add our 1 to both sides. If we do that, we have 2y equals negative 4. Divide both sides by 2, and we'll be left with y equals negative 2. Same thing for the 0. If we put in a 0 right here, we'll have 0 plus 2y equals negative 5. Divide both sides by 2, and we'll get negative 5/2. Same thing with the 1. If we put 1 right here, we have 1 plus 2y equals negative 5. Subtract that 1 from both sides, and we'll get 2y equals negative 6. Divide by 2, and we get negative 3. Put our 2 in, 2 right here. So then that will give us 2 plus 2y equals negative 5. Subtract our 2 from both sides. Negative 5 minus 2 is negative 7. Divide by 2, and we get negative 7/2. And last one, 3. We put 3 in where we see the x. Subtract our 3 from both sides. We have 2y equals negative 8. Divide by the 2, and we get negative 4. So let's plot our points so we can draw our line. So the first one we have is negative 1, negative 2. So right here, x is negative 1, y is negative 2. There we go. We have 0, and we have 5/2. So 5/2 is 4 and 1/2. So this would be like 1, 2, 3, 4, 5/2. There we go. 1, negative 3. So here's 1, here's negative 3. 7/2 would be like 3 and then a half more. So here we have 1, 2, 3, 4, 5, 6, 7. There we go, 7/2. And then 3, negative 4. There we go. Our dots are pretty close together, but we can connect those. Don't forget your arrows. And now we have a graph of our line. Another way that we can graph is using the intercepts. An intercept is where the graph crosses the x or the y axis. So we have two types of intercepts. We have the x-intercept and we have the y-intercept. Let's look at 5x minus 3y equals 15. To find the x-intercept, that means you put 0 in for y and you solve for x. So that would look like 5x minus 3 times 0 equals 15. So 5x equals 15, and in this case x equals 3. So our x-intercept is going to be 3, 0. To find the y-intercept, you put 0 in for x and solve for y. So that gives us 5 times 0 minus 3y equals 15. So negative 3y equals 15, and y equals negative 5. You put in 0 because if you're going to intercept or intersect the x-axis, then that means that you're on the x-axis, so you move 0 spaces up and down on the y. If you're going to intercept the y-axis, that means you need to be on the y-axis, so you are 0 spaces left or right on x. So if we graph this, we have x is 3, so 1, 2, 3, y is 0, that's right here. And we have 0, negative 5. So x is 0, y is negative 5, 1, 2, 3, 4, 5. And now we have 2 points. We can connect these points. There we go. And now we have the graph of our equation. Let's try again. So let's look at x minus 2y equals negative 4. So for the x-intercept, we put 0 in for y. So if we put 0 right here, then we're going to get x minus 2 times 0 equals negative 4. So x equals negative 4. For the y-intercept, we put 0 in for x and solve for y. So that means we have 0 minus 2y equals negative 4. So divide both sides by the negative 2, and y equals 2. We can plot our points. So negative 4, 0, negative 1, 2, 3, 4, 0, 2. Connect our dots, and there's our line. Let's try one more. Let's look at 4x minus y equals 0. So if we look at the x-intercept, we put 0 in for y, and we solve for x. So putting 0 in for y gives us 4x equals 0. Divide both sides by 4, we get x equals 0. Now to figure out the y-intercept, we put 0 in for x and solve for y. So that's going to give us 4 times 0 minus y equals 0, or negative y equals 0, or y equals 0. So now we have a problem. If we plot these points, notice we only have one point at the origin. We can't graph this line with only one point, so that means that we need to pick another. In order to pick another point, just pick anything that you like. Think about something that might work out nice. Think about something that gives you an easy value. Pick any point that you would like. So how about we just pick x equaling 1? So if we say let x equal 1, that's going to give us 4 times 1 minus y equals 0. So move your 4 over. Negative y equals negative 4, or y equals 4. Now I have another point I can plot. We have 1, 4. So if we look for 1 on the x and 1, 2, 3, 4 on the y, that's another point. So we can connect these, and we can draw our line. We have two special cases for different types of lines. Let's look at those. One special case of a line looks like this. It's just x equals negative 2. Now this is not a point because there's no y coordinate. It's not negative 2, 3, or negative 2, negative 5. It's x equals negative 2. So this means no matter what y is, x is going to be negative 2. So that means that no matter what y is, x is negative 2. So if y was 3, x would be negative 2. If y was negative 1, x would be negative 2. If y was 0, x would be negative 2. No matter what y is, x is negative 2. So that is a vertical line. Let's look at the same thing for y. So let's say that we have just y equals 4. So that means no matter what x is, y is going to be 4. So if x was 1, y would be 4. 1, 2, 3, 4. If x was 2, y would be 4. If x was negative 3, y would be 4. So regardless of what x is, y is going to be 4. So that is a horizontal line. So two special cases for when we are graphing our lines.